Hello, class. I know that I said that all of my videos would be under 15 minutes, and I'm aware that my last video was 17 minutes, but combination circuits are confusing. They're probably the most difficult part of this unit, and so I wanted to have the explanation of them and Kirchhoff's rules, which you use to solve them, all contained in one video. So, in order to pay you back for the suffer of listening to my voice for 17 minutes, I'm going to make this video substantially shorter. 19.4, we're going to be talking about some of the procedures that you all are going to be using for the lab and talking about how some different lab equipment could be used to calculate current and voltages in a circuit. Now, there are two different tools we can use in a lab setting to figure out some information about our circuit. The first, pictured on the left, is what's called a voltmeter, and as you may guess, that is a device that we can use to figure out the voltage drop across some element or some collection of elements. On the left, we have a voltmeter, that's the circle with the V, that is put in parallel with the resistor, and it tells us what the voltage is across the resistor. On the right, we have what's called an ammeter, that's the circle with the A in it. Now, ammeter is a little bit more difficult to figure out exactly what it measures, but think amps or amperage. The amount of current is measured in amps, and we use an ammeter to figure out what exactly that value is. So on the left, we can figure out the voltage drop across our resistor, and on the right, we can figure out the current that is leaving our resistor and going back into the battery. I mentioned in the previous slide that the voltmeter was put in parallel with the resistor, and that was done very intentionally. In order for a voltmeter to work, it shows you the voltage drop over the area that it is put in parallel with. So here, the voltmeter is put in parallel with this resistor, so it will tell us what the voltage drop is across this resistor. Now, this is consistent with what we've talked about in the previous lessons when talking about what happens with circuits in parallel. Remember, parallel circuits are going to have equal voltage drops. So the voltage drop across this resistor is going to be the same as the voltage drop across the voltmeter. Now, whenever you're inserting a device into a circuit in order to measure that circuit, or any physical system, if you're ever using something to measure a physical system, you have to be careful that whatever you're using to make the measurement doesn't affect the system. So here, if putting a voltmeter across a resistor completely changes the physics of what's going on in this circuit that we're trying to analyze, then we can't use that voltmeter. So voltmeters and ammeters have to have very specific physical properties. And you want to look at what their resistance is to figure out whether or not it affects the resulting circuit. So for a voltmeter, you want to have a very, 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 very high resistance, because if the resistance is very, very large, then the current that doesn't end up going across the resistor and ends up splitting up to go up top through the voltmeter is a very, very small amount. So the effect on this circuit is minuscule because of how big the resistance of this voltmeter is. Now, in your lab, you're not going to actually be doing any collections with an ammeter. However, knowing how they work is going to be fairly important for future labs that we do, and if you ever do anything else with electronics. So I'm going to just go ahead and real quickly kind of explain what's happening here. Now, when you're using an ammeter, it needs to be put in series, because for an ammeter, you're trying to figure out the current through our circuit. Because with series circuits, all of the current at every point in the series is the same, the current that's going to be going across this resistor will be the same as the current flowing through the ammeter. And so we put them in series because this is the arrangement that gets us the same current. So for ammeters, if we're trying to figure out the current, we put them in series with our circuit. As for the internal workings of an ammeter, An ammeter is going to have a very, very small resistance because when you put things in series, if they have a big resistance, it's going to have a big effect on the circuit. For it to be a proper measurement, we want to be able to insert it into our circuit and have it have no effect on the circuit. And so the way we do that is having an ammeter with a very, very small resistance. Like I said, this was going to be a pretty short and sweet video. So here's the quiz for you all for 19.4. First, how would you measure the voltage drop across the first of two resistors in series? So if we have two resistors in series, how would you figure out what the voltage drop is across the first resistor using a voltmeter? The next problem is to do the same, but instead of figuring out the voltage, we want to figure out the current. And instead of the resistors being in series, we're going to ask if the resistors are in parallel. So what is the current through the first of two resistors in a parallel circuit? Go ahead, work those out, put them on your quiz sheet, and I will check them all on block day right before we start the lab. Have a good day, everyone.